Welcome. The students, in this video we are going to discuss about periodic table and its importance and also properties of periodic table and variation of different properties of elements along the periodic table. So to begin with, let us understand the need for developing periodic table. So the need mainly arises due to the complexity involved in learning and studying the properties of different elements. So uh, it becomes very important to have such periodic table to make it possible the systematic study. So systematic study of elements becomes easy. So it is one of the important reason why we need periodic table actually. Because of periodic table, systematic study of elements becomes very easy, and also it helps in new discoveries and upgradation of chemistry of elements. So let us see what are different initial attempts made in terms of periodic table, developing periodic table, and who are the scientists. So initial attempts. So I would rather say genesis of periodic table. So first, initially it was the Proust who developed the initial idea of classification of elements. So he said all the elements are aggregates of hydrogen and properties are integral multiples of hydrogen. So his classification was actually based on hydrogen and its properties. As number of elements discovered were increasing, this primitive concept developed by Proust became insufficient to explain the details of the elements and properties. So with the time there was also a new addition of ideas and theories. So the next person who gave the classification, that who made the attempt of classifying elements, is Lavoisier. He said elements can be classified into metals and non-metals, and he also gave the idea of properties like electropositivity and electronegativity. He considered metals to be electropositive elements and non-metals to be electronegative elements. This theory was actually discarded as we found the presence of metalloids in nature. So later on it was Dubliner triads. So So Dubliner's triad initially uh, gave an idea of variation of properties along the periodic table. So if we see, according to Dubliner's triads, he said that this was actually initial attempt of arranging the elements in a particular way. So he said that atomic mass of middle element in triads is the average of other two. So basically he arranged the elements in three triads. So let us see what are the different elements he had arranged. He basically arranged the elements in group of three, like lithium, sodium, potassium, beryllium, magnesium, calcium. Then he also like phosphorus, arsenic, and antimony. So if we see the masses, the atomic mass of lithium, it is 7, and we can easily say that atomic mass of sodium is that of atomic mass of lithium plus atomic mass of potassium divided by 2. So 7 plus 39 divided by 2 is like 23. So which was matching. And this theory, this concept developed by Dubliner was for it was valid for some of the elements which we had already discovered, but there were also many exceptions, like it would not give exact value. For example, fluorine, chlorine, and bromine, for these three elements it did not follow. So like that you will see many elements which do not follow this Dubliner's triad. And also the existence of compounds like iron, cobalt, and nickel, all these were exceptions actually to the Dubliner's triad. So later on, looking at the inability to explain many things, these Dubliner's triads were also uh, scrapped, in the sense this also became invalid. So later on, the attempts made by Newlands became important. So the fourth person to develop the arrangement or the classification of elements is Newlands. So Newlands octaves. So he was the person to initially begin with the concept of periodicity. So he is the first man to give idea that periodic properties of elements are related with atomic mass. So concept of periodicity was introduced here. So according to him, when elements are arranged in increasing order of atomic masses, the eighth element starting from first will have similar properties. Basically, he introduced the concept of this periodicity. In his classification, we classify lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, calcium, and potassium and calcium. So these were the elements arranged by Newlands. Now if you look at the drawbacks of this arrangement, it's valid only up to calcium. There are so many elements today. So as the number of elements increased, his theory also became insufficient and incapable of explaining the many properties. And there was no concept of inert gas here. So did not discuss about the properties of inert gases. So no mention about noble gases, and it works well only for applicable only for lighter elements, So owing to these reasons, again Newland's octave was also not good, like it would not explain many things. So later on, Rothermere also contributed in classification. So this is E. Rothermere classification. Rothermere calculated atomic volume by dividing mass by density. So he calculated atomic volume as mass divided by density, and he plotted the graph of atomic volume versus atomic mass. So he plotted the graph of atomic volume versus atomic mass. So this curve was of this nature. So in this way, he observed that the elements of similar property occupy similar positions in this curve. So he found that alkali metals occupy top portions of the curve, that is the crest. So alkali metals like lithium, then sodium, then potassium, like this. So they were in the crest of the curve. Then alkaline earth metals occupy the middle of the decreasing portion. So beryllium, magnesium, calcium, and halogens would occupy the ascending portion. So halogens like chlorine, fluorine, they would occupy this ascending portion. Fluorine, then we have chlorine, like this, and transition metals would occupy bottom of the curve. So these are the observations made by Rothermere. And the very important drawback of Rothermere's classification is that it was of very low practical utility, because we most often don't use this concept of atomic volume only. So it did not talk about the variation of properties and like periodic properties are the functions of atomic mass. So because atomic volume is physical property, we would use it very less. So next person to develop a well-defined classification technique and developed the periodic law also is Mendeleev. So Mendeleev's periodic table. Actually, this was the well developed periodic table. So Mendeleev gave periodic law also. So according to Mendeleev's periodic law, periodic properties of elements are functions of their atomic masses. So based on this periodic law, he arranged the elements into a well-defined table. So in the original table developed by Mendeleev, he made 12 columns called as groups, and 7 horizontal rows called as periods. Then later on it was modified and modified to 9 column and 7 rows. So some of the aspects of Mendeleev's periodic table are even valid today. So the group and the periods of Mendeleev's periodic table is beyond the requirement for our syllabus. So we will only discuss about merits and demerits of Mendeleev's periodic table. So merits. The important merit of Mendeleev's periodic table is that he simplified and systematized study of elements. So it's the first and most important merit. And he also left vacant spaces actually in his periodic table, so that the invention of in the sense discovery of new elements became very easy. Then it was very useful in correcting the atomic masses of certain elements like uranium, beryllium, then gold, platinum, etc. So these are the merits of Mendeleev's periodic table. Then there are demerits. Demerits also are important. So the most important demerit of Mendeleev's periodic table is position of hydrogen was not very specific and it was not fixed. And he also did not spoke about isotopes. So he did not give a right justification to the position of isotopes. And also he did not mention the anomalous position of lanthanoids and actinoids. And he also placed the elements in incorrect positions, because sometimes what happens, like argon and potassium, argon has 40, mass number 40, and potassium has mass 39. So according to his law, the position of potassium comes before argon, but that's not correct according to the many properties as we see today. So in this way there were many elements which were misplaced in his periodic table. And to be more specific, Mendeleev's periodic table did not explain the periodic properties or periodicity more efficiently. So that's about the demerits of Mendeleev's table. So with this much information, we move towards modern periodic table.